Hello everyone, my name is Abhishek and welcome back to my channel. In 2025, can you think of a company that's not interested in Kubernetes? At least I can't. Either companies are already using Kubernetes or companies planning to onboard Kubernetes. The reason is simple. Kubernetes is the best platform out there for deploying and managing your cloud native applications. Along with that, there is a growing trend of AI workloads, ML workloads, agentic AI. Even in that space, Kubernetes is looked as the target platform. So overall, every company needs Kubernetes. However, there is a major challenge for companies using and managing Kubernetes clusters. That is costing of Kubernetes. A lot of companies find it difficult managing their Kubernetes cluster costs. In this video, I will introduce you to a platform called Cast AI. Cast AI is known for Kubernetes cost visualization as well as Kubernetes cost optimization. We will take a deep look at the platform. Along with that, we will also learn a lot about cost optimization and cost visualization. Make sure you watch it till the end. Especially this video is important for DevOps engineers and people managing their Kubernetes cluster costs. So Kubernetes costing is a major portion of cloud spend for organizations. There are companies who spend 60% or even 70% of their entire cloud spend just on Kubernetes. This makes it an important aspect of FinOps. We discussed about FinOps in our previous videos as well. We learned that FinOps plays an important role in cloud cost optimization, where Kubernetes cost optimization is a major aspect of it. Take a look at this case study. Project 44 onboarded Cast AI for cost optimization, and within 30 days, they were able to reduce 50% of their Kubernetes spending. Now, saying all this, let's see how Cast AI works, what are the features of Cast AI, and how to onboard Cast AI for your clusters. Towards the end of this video, I'll also talk about differences between Cast AI and Carpenter. So if you're looking for that particular portion, you can also get that towards the end of this video. Cool. So this is a platform and I already have a demo cluster connected to the platform. We will use this demo cluster in the video. Setting up an account with Cast AI is pretty straightforward. Either use the link in the description or in the pinned comment. By clicking on that link, you can set up an account using your GitHub account or one of your email addresses, and anybody can create an account. The best part of Cast AI for me is the user experience. If you look at this left pane here, even for the first timer, it typically explains what exactly Cast AI can offer. So it can help you with optimization of your cluster costs, which we discussed before. Along with that, it can also help you with visualization at granular level, and it can also help you with security of your cluster. So you don't need another SaaS subscription to manage your Kubernetes cluster security. Cast AI can actually do it for you. It can help you with compliance. It can help you with affected critical vulnerabilities, which resources or which workloads are affected by the critical vulnerabilities. And it can also help you with the attack path. Now, I know your first question is, but Abhishek, where do I start from? Very simple. You start with the cluster list section. Just click on cluster list and connect your cluster with Cast AI. It supports EKS, AKS, GKE, OpenShift, and Kubernetes cluster that you have created with KOPS. It supports all of these configurations. All that you need to do is just run this curl command. Make sure you run this curl command on your machine, which is connected to the Kubernetes cluster using kubeconfig. Because end of the day, it runs kubectl apply. So you need to apply the configuration from the machine, which can connect to the Kubernetes cluster. It takes few minutes for cached AI to connect to the cluster. And once you have it, you can see the cluster here in the connected cluster section. Perfect. So once you have your cluster connected, don't immediately jump to optimization part. Of course, cached AI can instantly help you with cost optimization. Its AI algorithms, its autoscaling feature, the Evictor that it has can actually instantly help you with cost optimization. But I personally recommend starting with cost monitoring. This is something that I prefer for my clients as well. And also, I explained this in the previous FinOps videos that start with understanding the cost. Cost monitoring can help you explain cost at the granular level. That is, how much your workloads are costing, how much are your namespaces costing, how much are you costed at the allocation groups. You can get all of that using cost monitoring. And Cast AI does exactly the same. For example, if you go to the cost monitoring and select one of your clusters, right? Let's say I select this cluster, it can actually help you understand the cost at the granular level as much as even your pods. So you can go to one of your pods, like I have a Scalator pod here. I can go to this pod and I can understand what is the current month spend of that pod. I can see the monthly forecast because Cast AI can use the AI algorithms and forecast the cost. And along with that, it can also show you the average daily cost. You might ask, but Abhishek, I want to understand the cost of a particular date rather than average date cost. You can also do that. If you just scroll down, you can get the cost for a particular date as well. And you can understand that from CPU as well as memory point of view. Isn't that amazing, right? And okay, just like how you can get that at workload level, that is pod, deployment, stateful set, you can actually get it at namespace level as well. This is where personally it helps DevOps engineers or somebody managing the cloud cost because a lot of times you tie namespace to a project. And when your management or somebody looking at FinOps, if they want to understand how much a project accounted to the complete cloud cost, this analytics are of great help, right? Maybe you want to see how much project X accounted to the complete cost. And maybe management want to verify the efficiency, right? Is it right for the management to spend so much on project X? You can get that information using this particular thing. I have 5 namespaces here, just like the pods. I can get current month spend. I can get average daily cost for that particular namespace and on a particular date as well. Apart from namespaces, for some organizations, let's say some MNCs, they also need at the allocation group levels. Some MNCs within the orgs have sub-orgs. Maybe you're dealing with e-commerce organization, let's say. A e-commerce organization might have a sub-org called payments, a sub-org called transactions. And rather than the project level, if they want to track at the allocation level, again for the same purpose, maybe management want to understand how much a allocation group is accounting to the complete cloud spend and do they really need to spend so much on that sub-org, right? They can get that from the allocation groups. Cool. And it also supports cost comparison. Now, once you spend good amount of time on cost monitoring or visualization, it will give you a great insight of your current cloud spend, how much you're spending, You can also analyze yourself, like, are you spending right? Why are you spending? You can have a discussion with your management, and then you can start with the magic of cached AI. Of course, even providing this granular level of uh, cost visualization is also something great. But once you have that complete picture, you can start with optimization of the cost, right? For cost optimization, primarily what cached AI supports is scheduled rebalancing. Why is it called scheduled? Because you can actually schedule it. I'll come to that in a couple of minutes. But what is rebalancing? So rebalancing is basically a cached AI feature, or it's a algorithm that it supports, where as you connect your Kubernetes cluster, like today I've connected my Kubernetes cluster, instantly cached AI will start understanding the node configuration. If you have created that nodes maybe let's say 3 months ago, and there are new node configurations provided by AWS, which are much cheaper, or you have a similar node in other families, like you might be using a T series, but there is another series which is much efficient in T series for you. Cached AI can start that rebalancing. So it will create new nodes and eventually remove the previous ones. So it has a complete insight about the latest node configuration. If you're using any outdated node configuration, it can immediately rebalance. And it is scheduled because maybe sometimes you want to don't want cached AI to do it during your daytime, or you might not want cached AI to during your work days. You can schedule this rebalancing over the weekends as well. And most importantly, you can do the rebalancing at the cluster level, or you can also do the rebalancing at particular node levels. And it also provides you algorithms like, highest normalized CPU or highest requested resource price, all that. And you might be wondering, but Abhishek, what about auto scaling? Okay, it can do rebalancing where it can remove the fragmented CPU, it can update your node configuration with the latest nodes. But what about auto scaling? Like something that Carpenter is popular for. Like, can cached AI also help me with auto scaling? Yes. So there is this auto scaling feature of cached AI where it can help you with upscaling of your cluster, and it can also help you with downscaling of your cluster. And downscaling is actually like a very good feature of cached AI where, let's say, there is a sudden spike in your traffic. What autoscaling usually does is it scales your number of nodes, right? Let's say you have a unexpected traffic and your nodes are scaled to, let's say, 100, and eventually the traffic comes down, and at the same time eventually your nodes also comes down, right? But what happens with usual automation platforms is that it takes some amount of time. But what cached AI can do is it can start its prediction and instantly, like instead of even taking that 4 to 5 hours, it can reduce the time for you. Maybe within 1 to 2 hours, it can actually downscale back to the original state. Now, this helps a lot. Maybe with 1 or 2 nodes, you might not see that, but when you are downscaling from 100 to 5 nodes, or downscaling from 100 to maybe 10 nodes, you can actually see that impact even for 4 to 5 hours. So cached AI can rapidly and efficiently downscale. At the same time, it can also auto scale, right? Very commonly, you might have some unscheduled pods because of lack of resources. What cached AI can do is it can either add a spot instance, or it can add, a efficient node according to your configuration or requirement, and it can automatically identify that required configuration for you. It can also create only spot only cluster also. Like if you want cached AI to create complete spot only instances cluster, it can also do that for you. And there is one very good feature in terms of optimization, which I explored with Cached AI, is the Evictor that it supports. So the Cached AI Evictor, what it does is, let's take this train analogy. Let's say you have a train, and this train has three coaches: coach one, coach two, coach three. And overall, the train capacity is 90, and each coach capacity is 30. Very commonly, people might be scattered, and you might have 10 people in coach one, 10 people in coach two, and 10 people in coach three. So, although you don't need three coaches, but people are scattered, what you can efficiently do, let's say you don't want your train to be loaded, or you don't want your engine to be loaded, right? You can put people from different coaches into one single coach, all 30 people in one coach, and you can remove the other two coaches, right? So what happens? The load on your engine gets less because you have removed two other coaches, and the efficiency is more. Similarly, even with Kubernetes, I think in most of the clusters, you have pods scattered, right? You have pods scattered because of the kube scheduler. You might not even have any of the pod affinity or node affinity, but still your pods are scattered. What Cached AI can do is it can automatically identify this. So they have this evictor where firstly it identifies the scattered pods. It tries to put everything in as much less nodes as possible, and it tries to free a node. As soon as a node is freed, it will remove the node, right? So this way it can actually shrink your cluster size by evicting some nodes as well. So it can help you with auto scaling, it can help you with downscaling, it can help you with eviction of nodes, it can help you with scheduled rebalancing, and much more that is mentioned in the documentation. Overall, even if you look at this demo cluster, like if you go back and in the optimization, in the visualization, if you select this cluster and if you want to see the savings, so this particular cluster, Cached AI says it can actually save up to 64.3%. How? By introducing all of these algorithms: downscaling, autoscaling, evictor, schedule rebalancing, and much more that is provided in the documentation. Right? So the usual cloud spend is 43,000 US dollars, where Cached AI, if you connect this cluster, it can actually bring it down to 15,000 US dollars. Right? Like it might be asking you to use spot instances, or it might be asking you to use Graviton, that is ARM support, and other efficient things for your cluster configuration. So we will do more demos on Cached AI because cost optimization is the thing in 2025, where whether you're using machine learning workloads or whether you're using traditional cloud native applications, your target platform is Kubernetes, and Kubernetes accounts to one of the major portion of FinOps. Every company is looking for cost optimization, where they look for Kubernetes automation. I hope you enjoyed this video, and I would definitely recommend you to try Cached AI with your EKS cluster or with your OpenShift. I forgot to do the comparison between Carpenter and Cached AI, which I promised. Uh, Let me tell you that a lot of people, when I did a brief video on Cached AI, people were asking about Carpenter, right? How Carpenter is different from Cached AI, because Carpenter is also open source. One thing to understand, Carpenter is open source, but it's not a free tool, right? So you can install Carpenter and you can actually use it for your cluster auto scaling, or you can use the Carpenter autoscaler. But as you install Carpenter on the workloads, right, you need EC2 instances where you have Carpenter, and you need people to manage Carpenter, where there is some amount of learning that you need to get used to the platform. And additionally, like, okay, even if you put that aside, like Cached AI is a fully managed SaaS platform, but even if you move that aside, right? From an enterprise point of view, what Cast AI can do is it can get your cost reduced when you compare with Carpenter. It can give you an efficiency of 20 to 25 percentage, right? Carpenter can reduce the cost, but Cast AI can do it more efficiently. And also, like Carpenter, although it supports different cloud platforms, but when you try to use it with GKE or when you try to use it with OpenShift, I don't find Carpenter as efficient as it is for AWS or EKS. So when you try to use Cast AI, it is hybrid cloud automation platform. It supports EKS, AKS, GKE, OpenShift, and also COPS. Along with that, it also comes with the security features like Cast AI. You can take a look at your image security and vulnerabilities that are impacted. One final thing when it comes to Cast AI and Carpenter comparison, at least from I've used both of these platforms. Uh, One thing that I found is the downscaling feature of Cast AI, which is much better. Cast AI, like when it scales up, like the autoscaler scales up and it takes to certain amount of nodes, downscaling is done very rapidly and very efficiently. So even that 4 to 5 hours or 2 to 3 hours that you saved during the downscaling is going to help you a lot because the nodes are costing you and you have huge amount of resources that are downscaled. So you will see that with Cast AI. So this is a comparison. I will do more videos on Cast AI as I promised. So see you all in the next video. Take care. Bye bye.